Hello and welcome to another video. In this video we're going to be working on subarrays with k different integers. And so in this problem you're given an array nums and an integer k, and you want to return the number of good subarrays of nums. A good array is an array where the number of different integers in that array is exactly k. So for example, here's 1, and so it's kind of similar to problems we did in the past. So in this first one, there's all the ones here, and second one, here's all the ones here. So I think an n squared solution is pretty easy, and it would just be something like this. So we have our 2 pointers, and we can start at like every possible start index, and we can just keep track of like how many elements we have, how many different elements we have in like a hash map or something. So we could say like let's say for this example, k is 2. Let's make this a little bit okay. So all we'd have to do is just grow this out. Like let's say this is our start index, we'd grow this out and be like, okay, we have 2 different elements now, and then that's one array. And then we just keep growing this out, and then as soon as it becomes invalid, everything past that will be invalid, right? So here we'll say like, okay, this is invalid. So for starting at this index, we have 1. Then we can start at this index, and we could be like, okay, we have 1 element, 2 elements. Okay, now we have something invalid. So same kind of thing. And then we can start at this index, and we can be like, okay, so this is too small. Now we have 2, so this is valid. Now this is invalid, and so on. So you can just keep doing this. And that would basically give it to you in n squared time. Pretty easy, just for every start index, keep growing it. As long as you have 2 elements, or whatever k is, keep growing it. And every time it's valid, just mark it down, and so on. But let's try to do this in linear time with a sliding window, and this is a little bit trickier. So actually change some of these numbers a little bit as well. So let's change this to a 2. Change this to a this is fine. Okay, so linear time is tricky because like you can make a sliding window, right? Because once again, contiguous, look for a sliding window. You can make a valid sliding window. Like let's say a valid sliding window. Let's actually make k instead of 2. Let's make it 3. So you can make and let's actually, for some reason it's this. Let's do this. There we go. So like let's say we have a sliding window, like what would it be here? Like this. That's valid. Well, it's hard to say what we do from here, right? Like, yeah, sure, this is valid, or like this is valid. But like how many subarrays do we have given this window? It's hard to say, right? Like how many do we have? Like, do we have 1? Do we have 2? It's hard to know. Like in other problems, we said like if something is valid, then everything past it or less than that is valid. And that's kind of the goal we want. But in this case, it's not really the case, right? Like, for example, this is a valid window, but that doesn't mean, like, all of these are valid. Like, it might not be. Like, or it doesn't mean all of these are valid. So you don't really know enough information from a given window. But what you can do is you can split this problem into 2 parts, and this is a little bit tricky to come up with, but you can split it into 2 parts for sliding windows, and then both of those parts are reasonably straightforward. So, part 1. Get all subarrays where count of unique elements is less than or equal to k. We'll get that. And then part 2, same thing, but now less than k. And so if we have all the elements that are less than or equal to k, and then we have less than k, we can just say, let's take, this is a and this is b, we can just do a minus b. Right? And then that would give us all the elements equal to k. And this is a little bit tricky to come up with, but essentially you just make 2 different conditions, and those conditions are pretty straightforward to come up with. So now let's walk through how we would do those. So the first one, all subarrays where the count of unique elements is less than or equal to k. So now we have a much easier problem because we know, like let's say this is a valid window, right? We know for sure now, like given this is the end index, we know for sure if this is valid. If we're looking for less than or equal to k for the count of the count of unique elements to be less than or equal to k, we know that if we shrink it, there can only be less elements, right? So if this whole thing, the number of elements is less than or equal to k, we know we can just shrink it down all the way to this, and we know all of that will be valid. So from that, we can easily do a sliding window. So let's kind of walk through that solution for a sliding window. And then we'll get a count here. So we need a couple things. We need a hash map, which we can just put on the left, and we need like our result on the right. So result will be 0 for now. So let's walk through this solution. So let's start over here. So we have 1 with a count of 1. And how many elements do we have? We have 1. Is that less than or equal to k? Yes. So our window is already valid. And how many subarrays are there given these 2 pointers? Well, there's only 1. So our result is going to be 1 here. Then we can grow our window. And the idea is we're going to try to make the window, we're going to try to make the biggest window possible. And then we know everything below that works, right? So here, our window, we have 2 with a count of 1. So we have 2 unique elements, which is still less than or equal to k. It's only 2. So every window with this end index, like this is the biggest window possible with this end index. So every single subarray with this end index from here all the way down will work. How many are there? Well, it's just the number of subarrays you can make, and the number of subarrays is just right minus left plus 1 here. So like this is a valid subarray, right? Like this is a valid subarray, and this is a valid subarray. So there's 2. So now our total result is 3. And then let's keep going. We don't even have to do like all of these. Maybe we can just cut it like here. Let's say this is fine. We don't have to like, it gets kind of repetitive, so we can just do this. Actually, let's see how long it takes and figure it out from there. Okay, so here 3 has a count of 1, and this is still valid. We're over here. And how many subarrays are there? There's 3, right? Because if this is valid, that means this is valid. That means this is valid. So now we have 6 total. Then 1 has a count of 2, but this is still fine because this is still like the number of unique elements is still k, so that's fine. So how many arrays are there here? So there's 4, so now we have 10 total. So 10. Then we grow this again, so we increment 2 to 2. So this is fine. This whole thing is still valid. So how many are there now? There's 5. So 15. Okay, now we finally have a sequence where it's not valid, right? So 5 has a count of 1. Now we have 4 different elements in here. So the length of our hash map is too big. So we got to shrink it until the length of our hash map is k again. So we're going to remove this 1. So we're going to remove the 1. Now 1 will have a count of 1. Then we will move this over. Then we will make 2 have a count of 1, but we still have too many elements. So we'll move this over again. Then we remove this 3, and now we're good. So now we have a valid window. So this is the longest valid window possible with this end index. Yeah, we remove the 3, and then we're over here, actually. Right, so 1, 2, 5, yeah. So how many valid subarrays are there? There's 3, right? There's this, this, this. So we just update our result to 18. Then we keep going. So let's try to speed this up. So 1 has a count of 2, which is fine. We didn't really change anything. So there's 4 subarrays here. So count is 22. Then here we have another, or no, actually we have a 2, and we already had a 2, so this is fine. So this is all valid, and we have 5 subarrays here. So 27 total. Now we have a 1 again, which is valid. So 1 has a count of 3 now. How many subarrays? 6. So we have 33. And finally, here we have a 3, which makes our window not work. So we have to shrink our window. So we're going to get rid of the 1. So the count of 1s will be 2. Then we're going to get rid of the 2. So the count of 2s will be 1. Then we'll finally get rid of the 5. So I'm going to show all those in like one step just to make it a little bit faster. So the first valid window is going to be over here. And now there are 4 subarrays here. So 1, 2, 3, 4. So our total result is 37. Maybe I did the math a little bit wrong in some point, but this is basically what you do. So we have 37 subarrays where the count is less than or equal to k. And now we're going to do part 2. So part 2 is going to be the same thing, but now we just want the count less than k. So it's going to be very, very similar, but we just slightly change it. So we just want to make sure that for a window, we want the count to be less than k. So it's kind of the same thing. It's very similar, right? So here, like let's say k is 3, so we want 2. So let's say we have something like this is a valid window. So if this is a valid window, that means this is a valid window. So it's kind of the same thing. We want the biggest window possible, and then any window below that will be a valid subarray. So this should be a little bit faster because the arrays will be a little smaller. So let's walk through that solution, or let's walk through like how to do that. So we're going to start again at the very start, and the code is going to be basically a copy paste of the first part with like a small change. So 1 has a count of 1. Let's actually just use text to make it faster. So 1 has a count of 1. This is valid. So we will record that. So right now our result is going to be, so this is like our second result will be 1. Then we grow our subarray. So 2 has a count of 1. This is valid. So we have 2 subarrays here. So now our result is 3. Yeah. And then here, 3 has a count of 1, but now we need to shrink it because we need to get rid of the 1 because this is no longer valid. So we shrink it like this, and then we have 2 subarrays here. So result is 5. And then we need to keep going. So we add a 1. So if we add a 1, then we need to get rid of the 2 to make it valid. So we have 2 more here. So result is 7. And then we add a 2. So 2 has a count of 1. Then we need to get rid of the 3. So this is kind of like all the same thing. And then we add 2 more. So this is 9 now. Then we add a 5 with a count of 1. So we want to get rid of the 1. And now this is 2 more. So 11. Then we add a 1. So we want to get rid of the 2. So let's just toss this out. 1 with a count of 1. Make this smaller. 2 more. And then we add a 2. Toss out the 5. I'm not going to write down the numbers. I think it's like pretty straightforward now. So we added 1. We added 2. Toss out the 5. So now we have 2 more. So this is 15. Then we add a 1, and this is still valid. So we don't need to shrink it anymore. So there's 3 subarrays here. So this is 18. And then we add a 3, and we need to toss out this 1, and then this is still too big, so we need to shrink it like this. So we have 2 more here. So maybe I did the math wrong, but essentially we have 37 subarrays where uniques less than or equal to k, and 20 subarrays where uniques less than k. So that means a difference. That means we have 17 subarrays where uniques equals k. And that's pretty much how you do it. You just break it down to two sliding window problems, and then it's pretty easy. But it's hard to do it in one. It might be possible, but it's definitely way easier to do it in two for things that you can get a lot easier, because you know, like, okay, I have my like biggest window possible, and then I could shrink it down. Kind of the same as we did last time, or before we made the smallest window possible, because we knew that everything below this was a valid subarray. So you kind of like want to think, how do I make windows so I can count my subarrays in O of 1 given some end index? And that's the case in this. So now we can code that up. So we're going to have a result variable, and we're going to have, what else do we need? So we need like a count or something, or actually we need a hash map, right? So we need a hash map of every variable and its count. And yeah, so we're going to have a map, integer, and this will be like counts or something, and this will be new hash map. Okay. Yeah, and then what we need a left, and that's pretty much it, I think. So now what we need to do is we need to just do a basic sliding window. So we're going to go through it. So we'll say like for int right equals 0, right is less than num's length, right plus plus. Then we are going to, so remember our first sliding window will handle every element, or the number of elements bigger or equal to k. So that's what we're going to do here. So we're going to say counts.put num's right, and then it's going to be its old value, so counts.getter default of num's right or 0 plus 1. Yeah. Okay, so what we need to do is we need to say, while the size of this dictionary is too big, we need to shrink it. Yeah. So we can say while counts, I believe its size is greater than k, we basically need to keep removing elements. And then if when we remove an element, its count is 0, we need to just remove the key. So we can say counts.put num's left And then this is going to be counts.get nums left. Whoops. Counts.get nums left. And then this will be just -1. And then we can say if counts.get nums left. Yeah, this comes if count get nums left is 0, then we need to remove this element completely because we're going to use the size to determine how many keys we have. So, or you could have like another variable if you want to. So we can say counts dot, I think it's remove nums left. And then we need to make our window shorter. So typical window format, kind of like we did in most of our other problems. So now what we need, like now given our window, all the, like given a window, like let's say our window is this, the number of subarrays we have is just the length of the window because it's going to be like this plus this plus this and so on. So if it's all here, there's only 1, 2, 3, 4 and so on. So it's just the length of the window here. So we can say result plus equals, right, minus left plus 1. So that's how many elements there are that are less than or equal to k. And now we can pretty much copy the code again. And then we can say, we can just say that, like we need the number of elements that are less than k now. So we can just take our old result and subtract those. So we can literally copy all this code, except we don't want to like reinitialize. So I wonder if there's like a count clear or something. Oh, we'll find out. I'm not sure what this method is. Hopefully it's this. And then we can make left equals 0 again, and we literally can copy paste the code. You can obviously like make this a little bit cleaner, but so there's like a small change here. So all we have to do now is, before we had it greater than k, now we have to say greater or equal to k. You can actually even do this. This will be fine because technically it'll just go up to k and then shrink down. So this is also fine. So instead of plus, we just do a minus here. And the rest of the code should work. Assuming this clear actually exists, which I'm not sure. So let's return the result. And this should be it. So let's see. This is remove. And remove. Okay. And that's basically it. So even though you're kind of copying the code, it's very, very hard, I think. Like, maybe you can come up with it. It's very, very hard to do this in one pass. So the easiest thing to do is just come up with 2 easier conditions, and then you can solve for both of those, and you just take the difference. So that's another like thing you can add to your sliding window toolkit now is, you know, I can run multiple sliding windows for different conditions, and then I can just take the difference if needed. So that is pretty powerful, and then you can like do a lot more things with that. But the nice thing is this is still going to be event runtime and space. We do have a hash map, so event space. So hopefully this is helpful. Definitely a tricky one to do with a one window. Let me know if you managed to do that. But I think once you realize you can do 2, pretty straightforward, especially like once you know you can do 2 and the conditions you're looking for, I think it definitely becomes like pretty manageable. Like if you don't know that one, then I'd definitely review like sliding windows in general and how to come up with these things, because it's very similar to things we did like the last few days. But regardless, if this is helpful to you, then please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.